We are going to continue our discussion on graphs and in this part about how we can implement them in C++. We are going to present two exercises. The first one, how we can create a class graph, and the second one, how we can implement a method for moving through the graph for visiting the nodes according to the deep-first search algorithm, DFS. So creating the class. So to some extent, to some degree, we are going to base our method like the adjacency list, the representation, where we have a vector of nodes of dimension according to the number of nodes in the graph. So here, if we have 7 nodes, it means that we have a vector of 7 positions. Each position will tell which are the, will have a list saying which are the neighbors of a node, of a given node. So for example, for the first position, for node 1, we have a connection with two neighbors, 5 and 2. So actually this is what we see in the graph. So we have a node 1 which is connected to node 2 and to node 5. Now, how we can represent this in C++? First of all, we are going to use the data structures provided by the standard template library. For example, for creating the vector of nodes, we have this declaration. So we have a vector to nodes. So later we will show how we can also create the class node. And notice that these are pointers to nodes. So why is it so? Because we want to create dynamically the nodes on runtime when executing the program. So what does it mean? So when writing, for example, the statement equal new node, so what happened in that way? It will happen that we are reserving a space on memory for placing the node object. So like I show here in this column. So this will be, for example, this can represent the heap of the computer when we are placing dynamically the nodes that are being created. And instead, then this vector will have just pointers to this node, to all these nodes. So we have the vector to the nodes, so representing the nodes. How we can now make a link, so in some way to represent the edges connecting these nodes. So we are going to use other data structure, which is a multimap so we are going to use the multimap structure from the standard template library. In this case, we have the multimap is a container having pairs. These pairs, they represent the connection between the nodes. So for example, the pair 1, 2. So this means that there exists an edge, so like we saw in the example before, between node 1 and node 2. And this other pair, 1, 5, it means that we have a connection, an edge between node 1 and node 5. Notice that, as we define it in the multimap, these are pairs of pointers to nodes. So you see that we are linking to values in the dynamic memory. And they themselves, they do not have the values of the nodes. So we are making the references by the use of pointers. Now, why multimap? It's multimap because you see that the pairs are key values. And for example, in a classical map, we cannot have pairs with same value of keys. So we could not have like this. In a multimap, instead, we can have pairs with equal values of keys. So you see here that we have two pairs and both of them, they have the same key value, which is 1. Now, moving to the code. So actually you can see that we have implemented most of the class graph. So I just will make with you some little adjustments. And we are going to explain it now. So you see that we included the packages, the libraries of the STL for manipulating the vector data structure and the map data structure provided by the C++ standard library. Now we have a template class, so it's a generic class. So this can be a graph of integers, this can be a graph of people, this can be a graph of places. And the idea is that the user of this class, when instantiating the graph, will indicate which objects, which class of objects the nodes are. Then the class node which is nested here. So this can be seen like as a factory of nodes, which is an attribute of the class graph, and this defines which is the structure of the nodes. So we have the private data of type T. So this is, you see that this is the T that we use here when creating the template. So this means that we have an attribute in the node of some object. We don't know which one now because this is a generic class. Now the method. So we have a constructor which is going to take as a parameter some data provided by the user of the type T, and then also we have some getter for getting the data value. We are going, as you see here, we are going to define we make here some data type definitions. This is the vector of nodes that we explained it before, and this is the adjacency list using the multimap that we presented before, which are going to make these links between the nodes. Now, which are the attributes of the graph? So then you see that we use these data type definitions here for making these definitions. So we have the nodes, and we have the adjacency list that represents the connection between the nodes using the multimap. Now the methods. So remember that if we are going to create dynamically things, this is the destructor of the class, and if we are going to create dynamically things, also we have to delete them. So whenever a program that is using the graph will finish, the destructor will be called for cleaning the memory. So for each node that we have defined in our vector, we are going to delete all the pairs that refer to that node, and then we are going to clean the heap of the dynamic memory using the sentence that we know, which is delete node. So now adding a node. So this will be called by a user whenever he or she wants to add a node in the graph. So giving us a parameter what the node will contain, what this new node will contain. So now let's complete it. So the first thing that we have to do is to create a pointer to a node, because as you see we have pointers to node, and make it the statement of new node. So here we are creating a new node dynamically, and we are going to push it in our vectors of nodes, of pointers to nodes. And this will be returned to the user. So why will be returned to the user of the class? Because then the user of the class will have a reference to the node. And we will show this why this can be useful. Then, for the adding edge, so we already implemented the method for adding nodes. So now a method for adding the edges. So the user of this class will give as a parameter a pointer to the node, for example, a pointer to a node that he or she already used before, using, for example, this method, and to the destination of the edge. So now we will complete. And what do we have to use here? Here we have to use the other structure that we defined, the adjacency list. And we are going to insert a pair here. So also we are going to use this class provided by the standard template library, a pair, and the pair will be of node pointer and node pointer, and source, which is the first node provided by the user, and destination. Now we have to close it here, and that's all. Now, how we can test this class that we have defined? So now we are going to move to the main, and here we are. What we could do? We could create a graph class calling to that class that we have defined. You see here that there is an include, so we are including in the file where we define it our graph. And for example, let's create a graph of integers. So we create here a graph of integers, call it graph. And additionally, let's suppose that we want to this graph to create a node and with some value. So let us create a node. So you see that I am using the inner class of the graph. So it's a pointer, so no1, for example, equal to graph at node. So for example, remember that here I have to add which is the object, so in this case an integer that the node will contain. So for example, put in 1, so the integer value 1, and let's print, so to see if everything is okay. So we are going to use here the print of C++. So remember that it's a pointer, so we need to make this construction. So we are going to refer to the method of getting the data from the node. And here we finish it, printing the end of the line. Then we are going to compile our example, and then we are going to execute it. And you see that the graph was successfully created. You see that the node was successfully added, and we printed its value.